So today we are going to start digital electronics, right? So as you know, in digital electronics, we generally study the signals which are having two values, either 0 or 1, right? We are having two values, zeros and ones. We are dealing with that one. It means in digital electronics, there are only two things, either there is 0, either there is 1. What is the meaning of 0 and 1s? How your computer will understand that what is 0 or what is 1? Anyone know that thing? Zero represents, generally we represents the 0 by 0 volt, and 1 will be represented by 5 volt, right? So basically your computer will understand either it is 0 volt because the voltage signal will travel through the your computer systems, right? That's why it is understand that is the 0 volt, there is no voltage. 1 means there will be 5 volt. So we will generally give the signals like this to your computer. Okay. If we talk about digital electronics, we are having variables. What is variable? Can anyone tell what is variable?
Values may vary.
Values may vary. Generally, if I defined a variable x in your normal system, or you can say in your algebra, if you are defining a variable x, x can take any value from minus infinity to plus infinity, right? It can take any values. But in digital electronics, generally, if I assign a variable means whose value can change. So if you are assigning a variable, or if you are defining a variable a, that can take only two values. Either it can take 0 or either it can take the 1 value, right? Hmm. 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 हाँ जी. Hmm. 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 Yeah. So we are having a variable a which can take two values, either 0 or 1. Right? Remember that thing. Basically, inside your electronics, let us take digital electronics. If you are defining a function like a dot b plus a, what is the meaning of this one? That first we are doing the AND operation here, A and B, then we are doing the OR operation for the complete you can set of equations, right? So basically if I implement this one, if I implement this function by using the Boolean algebra, sorry, not Boolean algebra, the basic gates. Second. If I implement this function, so what is happening? We are having A and B. Then we are having the result and we are doing the OR operation with both A. So that will be F. So what we are seeing, how many gates we require to implement this function? There are two gates, one AND gate and another one is OR gate here. So to implement this function, we require two gates, AND gate and OR gate. So if I use the Boolean algebra here, I can take A common, or I'm minimizing that. B plus 1 is 1, so it's going to be A. So generally if you directly connect that with the A with F, that will result the same thing, which will be result by this circuit. So basically whenever we are implementing in digital electronics, whenever you are implementing any function, first thing what will come into your mind, that we have to minimize that function. Understood? We have to minimize that function, right? What is the benefit of minimization? The first benefit of minimization is that it is required less number of gate. Let us take this gate. The first gate, we are requiring two gates. Let's take this first gate takes 2 nanosecond to generate its output, and the second gate will generate the output after 3 nanosecond. So what is happening? After applying all the inputs, output will be generated after 5 nanosecond. So there will be delay. If we go with the minimized circuit here, what happen? We apply a input A and we are taking a output F. So it means through this wire there will be no delay. So whenever you minimize a circuit, the first thing what we minimize the number of gates. Due to minimization of number of gate, right? Due to minimization of number of gate, the propagation delay of the circuit will also reduce. Like in this case, the propagation delay of the circuit is 5 nanosecond initially. It will be minimized to 0 nanosecond, right? As you apply the input here, at the same time you are getting the output F, right? It means the delay of this circuit is 0 nanosecond right now. Previously that was 5 nanosecond, now it will be 0 nanosecond. Understood? So that main thing is the benefit of minimization. So what are the benefits? First is propagation delay, less number of gate. Another benefit is what? See, whenever you see this circuit, every gate has its power dissipation. Means whenever the current will flow, whenever you apply the input to the gate, what happen? Every gate has its delay. No, not delay, the power dissipation. Means whenever the current or voltage flow inside the gate, it will dissipate some amount of power. If you are having if you are having higher number of gates, let's take you are having 3 to 4 gates, that will dissipate higher number of power. If you are having less number of gate, that will dissipate the less power, so power consumption is reduced. So basically whenever we are making any circuit, the first thing which we do, we are trying to minimize that circuit, minimize that expression. Why we are minimizing? So that after minimization the number of gates are reduced. As number of gates are reduced, p- power dissipation will reduce, delay of the circuit will reduce, complexity of the circuit will reduce, cost of the circuit will reduce, right? So before moving to further, we generally understand what are the operations. So basically the Boolean algebra is the method to minimize a logical expression. Okay, so before starting to Boolean algebra, the rules of Boolean algebra, right? We are starting with some different logical expressions like and sorry, before going to end, let's discuss about not gate or not operation. So you are having a variable a. Not means what? We are doing the a bar, right? If your variable a value is 0, then its complement or not is going to be 1. When your variable value is 1, not value is going to be 0. So that will be the truth table for the not gate. If your variable a is 0, then y or output will be 1, right? If your a value is 1, then output will be 0. This is called not operation. Next one is AND operation. The theory which I discussed, what is the benefit of Boolean algebra, that will be more important for this exam. Remember that, right? We are talking about the AND operation. AND operation means what? Let's take, we defined y is equals to a and b. This is not multiplication. Always remember, this is AND operation. If I put the dot in between two variables, that means that is a AND operator here, right? If you are having a and b and output is y, so a and b are taking how many values? Let us take. A and b is 0 0, 0 1, then 1 0 and 1 1. These are the four combination for this value of a and b. If a is 0, b is 0, then AND operation is 0. A is 0, B is 1, then only 0. A is 1, B is 0, then only 0. And if A is 1, B is 1, then AND output will be 1. You have to memorize these tables, right? This is AND operation. Got it? Next is OR operation. Before moving to OR operation, let's discuss something about that. A and A is how much? Can anyone tell? A and A is how much?
1.
1. Okay, any other?
A,
A. Okay, let's see. That will be A. See, basically, in this case, both the variables are same, right? If your A value is 0, the second variable is also 0. Go to this table. When A and B both are 0, the output will be 0. Let's take A is 1, then another A is also 1. Whenever both the input are 1 1, then output will be 1. So what we are seeing here, that the same value which we give to A, the same value will be coming out in the output. So what we can say, that if I give the A as an input, then the output will be also A. So remember this, A and A is going to be A. Understood? The first thing. Tell me, then I will move to the next thing, because these are the rules and which you have to remember for future, right? See, one more thing, whenever I am teaching, right? Yeah, correct. So just unmute yourself, right, and then tell the answers, because it is not easy for me to check every time the chat, right? Just unmute and give the answer. Okay, don't write in the chat. Okay, A into A bar is how much? Try to find its value. A into A bar.
0,
A
Yeah,
bar only.
it will be
it is
0,
0.
not A bar. Yeah, you can check it like this. Same way which we discussed previously. A value is 0, then A bar is going to be 1, right? So A 0 into 1 is going to be 0. Right. Next time, if you take the A value as 1, then A bar is 0. So it is going to be 0. So what we observe from these two values, that if your A is 0, then only output, then output is 0. If A is 1, then also output is 0. In both the cases, output is 0. Either you can take the value of A as 0 as 1. So what we can say, that the A and A bar is always going to be 0. Understood, everyone?
Yes, sir.
Yes, sir.
Next. A and 0 is how much? Tell me.
0,
0.
0,
0.
Very good. Very good. A and 1 is how much?
A,
Ones.
A,
A. It will be A. I take the 0, then output is 0. Take A1, then output will be 1. So it will be equals to A. Got it? So what was the final results are here? That A and A is going to be A and A bar is going to be 0. Then A and 0 is going to be 0. A and 1 is going to be A. Check and tell me. These are the four results. for the AND operation. If anyone have any doubt in this one, then please ask. Otherwise, I am moving to the next thing. Yeah, tell me.
Hello, sir. Just now
Yes,
only I
please.
have started. Just now only I have joined due to some technical issue. Can you revise quickly, like 2 to 3 minutes? I can catch it.
See, basically we discuss about the not operator here. Not operation is means a value is 0 and 1. If your a is 0, a bar is 1. If a is 1, then a bar is going to be 0, right? Similarly, we discuss about the AND operation. AND operation means a and b, right? Output is equals to a and b. So we make a table that a can take two values 0 and 1, and b also take 0 and 1. We make a 4 combination for that one, that is 0 0 0 1 1 0 and 1 1. These 4 combinations are possible for a and b. Similarly, we got the output y. When whenever you are having a AND operation, the AND operator output is 1 when all the inputs are 1, right? That's why when all the input means both the values of a and b are 1, then output is 1, otherwise it is 0. Then we discuss about that if I have a variable a and a, then what it will be equals to. So if a and a, then a and a, if a takes 0 value, then a no, sorry 0 and 0 is going to be 0, and 1 and 1 is going to be 1. So what we are seeing, the value of a is directly reflected at the output here. Similarly, if you are having a into a bar, that will be equals to 0, right? If your a value is 0, right, then a bar is going to be 1, then 0 and 1 is going to be 0. And if your a is 1, then a bar is going to be 0, that's resultant will be 0. So if you take the a value 0, then output is 0. If you take the a value is 1, then output is 0. So if you take any value of a, output is always 0. So what we can say, a and a bar is going to be 0. Similarly, a and 0 is going to be 0, a and 1 is going to be 1. So we observe these are the 4 results which you have to remember for the future AND operation. That if you have a, that will be a and a bar is 0, a and 0 is 0, a and 1 is a. Got it or not? We discussed these things.
Okay, okay, got it, sir.
Yeah, next is OR operation. OR operation means what? Output y is equals to a or b. This is not plus, it is or here, right? A, b, output y. 0 0, 0 1, 1 0 and 1 1. So OR operation means either any one of the input is 1, output will be 1. Either any one of the input is 1, output will be 1. So it will be 0, then 1, then 1, then 1. So this is the truth table of OR operation, right? I think everyone familiar with this one. Don't we think that it is a plus. If it is a plus, then this 1 plus 1 is going to be 2. But not. It is not the plus operator. It is a OR operator. So in OR operation, what is happen? If I take, let's take it here. A or A. Tell me how much is this?
A,
A. A, sir.
A.
A,
Very good. Or A bar is how much?
A,
A, sir.
1,
It's going to be 1. Check it.
Mm.
See, if your A is 1, then A bar is 0. So output will be 1. If A is 0, then A bar is 1. Then only output. Then also output is 1. So what we are seeing in both the cases, output is 1. Got it? So that means A or A bar is going to be 1. A or 0.
A, A, A होगा.
Very good. Very good. A or 1 is how much?
1. A. A.
A, sir.
It, it will be 1, not A. Check
Yeah.
it. A is 0, this is 1, output is 1. A is 1, this is 1, output is 1. In both the cases, output is 1. Got it? So it means either A can take 0 or 1, output is always 1. That means A or 1 is going to be 1. Got it? So the result is main result, the four results which we got from here. A and A is going to be A, sorry, not and, it's or A bar is going to be 1. A or 0 is going to be 0. A or 1 is going to be 1. These are the four important results. Check and let me know if
So the
anyone
A
have
plus
any
0 is A,
doubt.
right?
Yes, please.
A plus 0 is the A, right? You have mentioned it as
Oh,
a.
sorry. A plus 0 is A, not A 0. Yeah, that's A. Anyone have any doubt in this one? Then please ask. Otherwise, I'm moving to the next thing.
No, sir.
Right. Okay. Now we are moving about the Boolean laws. The first Boolean law, both and or operation are commutative in nature. So the first law is commutative law, right? Commutative law. Commutative law means what? A and B is going to be B and A, right? And this is called commutative law. A or B always equals to B or A. So it means both and or are follow the commutative law. Remember this, because sometimes he is asking that which operator will not follow the commutative law, which one is follow the commutative law. So you have to understand that these two laws are follow the commutative law, right? Second law is that associative law, right? Associative law is what? A and BC is equals to A and B then and C. Similarly, the OR operator will also follow the associative law that A plus BC is equals to A plus B plus C. Next, the third law is distributive law. Distributive law means what? A and B plus C can be written as A and B. The A will be distributed. I think this also already come in your last exam, the FT exam of this CSC. This law that A and B plus C is going to be A and B plus A and C. So he says that which one of the following represents the distributive law, right? This is distributive law. Got it? So there are three: commutative, associative, and distributive law. Okay. How much is A bar bar?
A.
A.
That will be A. It is another law, remember, right? Okay, one more thing. A and A plus B is how much?
A, sir.
Solvent. It's going to be A.
A.
How it will be A?
Sorry, sir.
A plus
A plus B, sir. Sorry. A plus AB.
So is it AB, sir? A plus AB.
A plus
A plus
AB, sir.
AB.
Okay, let's start.
That is
Just
B.
fo- just focus here. I
Sir,
just apply the distributed law here, right?
it's A only, sir.
A only. Yeah, A and A plus A and B. I apply the distributed law or not?
Yes, sir. Yes, sir.
So how much is the first value? Tell me. A and A.
A.
I already discussed this thing. This is the A. Then plus A and B. Till here everyone understood what I did or not?
Yes, sir. Yes,
Now
sir.
I can take the common A from these two terms. So it is become 1 plus B. 1 or B.
Yes, sir.
Check and let me know. Is it correct or not?
Yes, sir.
So now tell me 1 plus 1 or B is how much?
1.
1. So it's going to be A and 1. A and 1 is A. So this is called absorption law. Absorption law is what? A and A plus B is going to be A. Similarly, if I only have A plus AB, this is also A or not?
Yes, sir. Right, sir.
Similarly, we already discussed these things. And if I write A plus A bar into B, that is how much? Okay, leave it aside right now. We will discuss it later on. Don't worry.
Sir, A plus B.
Yeah, A plus B. Correct. We will discuss it later on because I think I need to discuss something else. Okay. First, tell me how much is this? Everyone solve and tell me how much is this?
A plus BC.
A plus BC. Anyone else?
Sir, A plus BC.
A plus BC. Good. So basically, what we did, everyone, yeah, we just multiply the two things. First, A and A. That will be A and A. This is the simple algebra which you already studied, right? Then A, first A go here, then A will go with this C, A and C. Then B goes here, A and B. Then B goes here plus A and C. Check and tell me. Everyone understood?
Yes, sir.
Oh, sorry. This is B and C. B and C. The last one is B and C. Okay. The first term is A and A is going to be A and C, then A and B, then B and C. Check it. Is it correct?
Yes.
From the first three terms, what thing we can take common?
A.
A.
A. So take A common, that will be 1 plus C plus B or BC. Check. Is it correct?
Yes, sir.
Now, 1 or C or B is how much?
1.
This term. 1. So it's going to be A or BC. So how we remember the both the direction it is true. I'm telling you. Yeah. How we remember this property of Boolean algebra, that here this A and this A is common. So which variable is common, that will come only once. And the rest of the two variables are multiplied together or and together and write on the second time. Got it or not?
Yes.
This is in opposite direction. It is also true that if you are having A or BC, that can be written as first A will go with B, A or B, then A will go with C, A or C. Okay? Either you go from this direction to this direction, or you can go from this direction to this direction if it is required. It will be depending on the requirement of the question. Both are true. Both are true. Correct?
Yes, sir.
Now move to that question. A plus A bar B.
AB. Sorry, sir. A plus B.
A plus B.
Very good. A plus B. So just distribute it, right? It can be written as A plus A bar, like we discussed here, and A plus B. Everyone understood? I just apply this one. The previous property which we discussed, that A plus BC is equals to A plus B, A plus C. So it will be A plus A bar into B. That will be A plus A bar, A plus B. And A plus A bar is going to be 1. So 1 and A plus B. That is going to be A plus B. Everyone understood this thing or not? Tell me.
Yes, sir.
Yes, sir.
Good. Write down one more question. Simplify the following expression.
B.
Very good.
B.
B,
B,
Good.
sir.
sir.
Very good.
B.
Let me discuss it. From first two terms, we can take the B common. So that will be C plus C bar. Then B into A. So C plus C bar is going to be 1. So B plus BA. We can take the B common. It will be 1 plus A is going to be B. Understood?
Yes.
That is how much. So before doing to this question, we have to study the De Morgan's theorem. De Morgan's theorem. De Morgan's theorem says what? If you are having A, let's take A or B or C like that, and you are taking the complete bar of that one, that means it will be equivalent to, always remember, the AND will be converted into OR and OR will be converted into AND, and individual will take the bar. So it will be A bar and B bar and C bar. This OR operation will convert it into AND, right? Like dot dot dot. Similarly, if I have A and B and C bar, complete bar, this can be simply decomposed into A bar plus B bar plus C bar plus dot dot dot. So AND will be converted into OR, and the bar will be distributed for the each variable like this. Got it? Now do this question.
B bar, sir.
B bar.
E plus B
B
bar.
bar. B plus B bar. Yes, that's the correct answer. B plus B bar. B plus B bar is how much?
Sir, C plus B bar, sir.
Okay, C plus B bar.
B bar, sir.
B bar.
Sir, B bar only.
C, sir.
Okay, let me discuss. See, y is equals to C, and that B and B bar complement can be written as B bar.
Plus C bar.
Very
Sir,
good.
1.
Now C plus C bar is how much?
Sorry, sir. C 1 plus B bar.
C
And
plus
1 plus B bar is how much?
1.
C.
1. Sorry, that will be 1. Everyone understood?
Yes, sir.
If anyone have any doubt, just tell me. I can give the answer right now, right? Don't be hesitate. Next question. Check it and tell me what will be the answer for this one.
Sir, A B bar.
A B bar.
A B bar. Correct.
A B bar, sir.
A B bar. So how we can solve it? A and B bar. So it is A. This is B or C complement. So that can be written as by using De Morgan's theorem. B complement, C complement. And B, it will be B bar and C bar. A and B bar, then A and B bar and C bar. And then B into B bar into C. So C bar. B into B bar is going to be 0. So that complete term is going to be 0 here. So now we will left A, B bar is common, 1 plus C bar, and 1 plus C bar is 1. So it is A, B bar. Check and tell me, everyone understood? Anyone have any doubt, then please ask. I will repeat that thing again.
Yes, sir, I have doubt.
Yes, please.
Sir, in third step, A into B bar into C bar is there, na, sir? How
A
A,
into B bar into C bar, right? So if you
yeah.
take the common from these two terms, A into B bar, then how much you left?
No, sir, in second step, I am telling.
Okay, in the second term, yes, please.
A into B bar into C bar is there, na, sir? B bar and C bar.
Yes.
How you have taken A, B bar and C bar?
I just remove the bracket.
It will be like a B bar and A, C bar.
Yeah, it is A, B bar, and C bar. No, it's not over here. Okay, let's take you are writing 2 into 3 into 4. How you read it? Tell me.
2 into 3 into 4 only, sir.
Right, that same thing is here. It
Yes.
is A and B and C bar. Understood now?
Yes, sir. I thought 2, 3 and
Yeah.
2, 4 like that.
Yes, yes. You think that there will be or operator in between them. That is not,
Yeah.
that is and operator.
Okay, okay, sir.
That's why I give this example. Understood, everyone? Anyone else has any doubt?
No, sir.
Good. Okay. One more question. Let A star B represents A bar plus B and C is equals to A star B. Then C star A is.
Sir, A bar plus B.
A bar plus B. That's not correct.
Sir, A square plus A plus B. Brackets.
A square. How you got A square?
Sorry, sir. Sorry, sir.
I solve it again.
B.
B. B is not correct.
Sir, AB.
A, B also not correct.
One.
1. 1 is also not correct.
A bar plus A dot B bar.
Let me discuss, right? Okay. So the first thing which we have to calculate C star A. C star is going to be how much? C bar plus A. Tell me that. Am I correct or not?
Yes, sir.
Yes. Now replace the C value. C is A star B, then complete complement plus A. Right? I am teaching you little bit higher from the BEL exam. Right? If the paper is become little bit harder, then you can easily solve that one. I'm not discussing only the basics of that one, right? I'm making one step ahead of that thing, that if the paper is going to be little bit harder, then you can tackle that one, right? From these things you can tackle the gate problems also, but are not that much harder problem which are asked in the gate, but you are able to tackle them. Okay, then A star B is going to be how much? I have to put that value. That will be A bar plus B, then complete complement A. Everyone understood what I did or not? Tell me, I will repeat that thing again.
Can you please explain the first step?
Sir, repeat from first, sir. Repeat from
Okay,
first again.
okay. I'm going to start from the starting. See, what is written here? Tell me that thing. What is written here? That if you are having A star B, that means you have to do the A bar, means the bar of the first variable, then or the second variable as it is. That the meaning of this operator star. So it means we are having two variable here, C and A. So we have to take the bar, means complement of first variable and second variable as it is. Tell me now, everyone, understood or not?
Yes, sir. Yes.
Should I repeat this thing or not?
Go ahead, sir. Next step.
Yep. The next thing is that you have to replace the value of C. See what we are seeing from this expression, what is given to you here, that here C is equals to A star B complement A. Tell me this one.
Right, sir.
Right. Now again you can write A star B. A star B is how much? A bar plus B complement plus A. Check and tell me.
Right, sir.
Now we can apply the De Morgan's here. So what we can say, A bar bar, then OR is become and B bar plus A.
A plus B
So
bar.
yeah, it is A and B bar and A. Right, because A bar cancel out each other, then it will be remaining A. And now A is common, it will be 1 plus B bar, and 1 plus B bar is 1, so it is results A. So don't give the answers in hurry, just solve it. Right, just solve each and every step, then you will get the correct answer. Everyone check it and tell me if you have any doubt, then please ask. Don't be hesitate.
Can you please go back to De Morgan's theorem once?
Yeah, this one is the De Morgan's theorem.
Just a minute. Sir, thank you.
Right. This is a good question, right? But it will not come in the BEL exam. But you will better understand the things if it will come like this. Then how you can tackle these things, right?
Sir,
If anyone
first,
Can
told you,
you tell me the double bar thing? 1 second.
okay, double bar means let's take you are writing a bar. One more thing again. A is taking 0 and 1 value. Then a bar is how much? That will be 1 and 0. Understood? This one you already know or not?
Okay, sir. Next.
Right. Next thing is what? If I take the double bar. Double bar means again the bar of the A. So it will be become 0. It will be become 1. So what we are seeing? These two values are same or not? Tell me.
Yes, yes.
So it means if you have double bar, it means the bar cancel out each other and you will remain with A only.
Okay, sir.
Right.
Sir, but in third step, no, I am having some doubt. In
Yes,
third
please.
step, how it came, actually in second step, A star B whole bar is there. How it converted
Right.
into A bar plus B whole bar?
Yeah, I'm directly putting that value from this expression, the first expression which is given in the question.
Okay, sir. Okay, sir. Okay, fine.
Right.
sir, I'm not able to understand this problem.
Okay, what is the problem? What thing did you not you are not understanding?
Yeah, how come C star A become a C bar plus A, sir?
Okay, let's take, I defined one thing, that is A star B is equals to A bar B. This is the star operator is defined like this, right? This star operator is defined like this. Now what I did, in place of A I replace the C, in place of B I replace A. So where you see the A, you have to replace C in place of A. Where you see the B, you have to replace A. Now you understood or not?
Yes, sir.
I just replaced this A with C, this B with A. So we got this expression now. Understood? That's why I write it C bar plus A here.
Yes, sir. After that, A star B bar.
Yeah, what you are seeing, this second expression which is given in the question here, can you see?
Yeah.
That will be C is equals to how much? A star B. So I just replace the value of C.
Okay, sir, I got.
Okay, tell me next.
I understood, sir. Thank you.
Right, and then A star B is going to be A bar plus B. That's I replace, and the rest of the thing I solved it here. Anyone else? No.
No, sir.
Okay, I think everyone understood this thing, right? Next is basically all the Boolean expression can be realizing using gates, right? Logic gates. So now we are going to discuss some basic logic gates. So basically, if I'm talking about logic gates, some basic logic gates are AND gate, OR gate, and NOT gate. These are the basic gates, three basic gates. Generally, if he says that you have to implement a circuit using AOI logic, this is called AOI logic. AOI logic means what? And, or, inverter. Inverter means NOT gate. I am discussing every gate individually, but sometime he give you the name. The AOI stand for in logic gates. AOI means and, or, inverter. Remember, so these are the three basic gates, that and, or, and not. . After that we are having two more gates, that are NAND gate and NOR gate. These two gates are generally called as universal gate. What is the meaning of universal gate? Universal gate are those gates with the help of a NAND gate you can implement any logic function without requiring any other gate. You can implement any logic function with the help of NAND gate and NOR gate individually. I am not saying that combinedly. If you are having only NAND gate, you can implement any function. If you are having only NOR gate, you can implement any logical function. Right? You can't implement with the help of AND gate, you can't implement every logic function. You required AND gate, OR gate, or NOT gate, right? Or a combination of all of them to implement all functions. But with the help of NAND gate and NOR gate, you can implement any logic function. That's why they are called as universal gate. Understood or not? Tell me that thing. What is the meaning of universal gate, right? Next are the category of gates is XOR gate and XNOR gate. These two gates generally called as arithmetic gates. Right, because with the help of these gates, we can implement the arithmetic operation like addition, subtraction. That arithmetic operation can generally be performed with the help of XNOR or XOR gate. So these are the three categories of the gate. Now we will start with AND gate. AND gate, this is the symbol for AND gate. You are having A and input is B, output is Y. I already give you the truth table. Should I write it again or not? I think no need to write it again because we already discussed. The output A, Y is equals to A and B. If you want, then I will write it. Otherwise, we already write it here in the starting. Yeah, that is the truth table of AND gate, right? You can just take the reference from here because we already discussed, then I'm not going to discuss it again. So this is the symbol for the AND gate. Next is OR gate. OR gate symbols are generally like this. This is A, this is B, output Y is equals to A or B. Next is NOT gate. This is A, this is A bar. Right, again output is Y. Truth tables I already discussed, so I'm not going to discuss it again. Yeah, this is NOT gate. Yeah. Now we are moving to the next category. Now I'm discussing the things. Next is NAND gate. So whenever you see NAND, NAND means not of a AND. You are having an AND gate and we apply at the input of a NOT gate. So it is A, B. So what we are getting here, A and B. And at the output here, we are getting A and B complement. So generally the circuit symbol for the NAND gate is represented like this. A, B, and output will be A and B bar. So basically this NOT gate will be replaced by this bubble. So whenever you see a bubble anywhere, that bubble will represent a not gate. Remember that thing. It means there is a not gate. So first we are having a AND gate. At the output we connect a bubble. Bubble means we are doing the note of that thing. So this A and B bar can be written as, by using the De Morgan's, what we can write it? A bar plus B bar. It means the alternating symbols for this NAND gate is going to be like this. If you are having a OR gate and you give the note, you do the note of A and B at the input, then it will be resulted as A bar plus B bar, which is also NOR gate, right? So the alternating symbols for NOR gate, there are two symbols for not NOR, NAND gate. There are two symbols. This is first NAND gate, and the second symbol for the NAND gate is like this. There are two bubbles at the input that will give you the same expression. It is A B bar, that will be A bar plus B bar, and here we directly got A bar plus B bar, which can be written as A and B complement. Everyone check this and tell me, did you understand the expression or the circuit symbol for the NAND gate?
So in the second one, we are using OR gate
Yes,
with a NOT.
OR gate. This is OR gate, right? Okay, let's move further. So what will be the truth table for this one? So it's just invert. You can say invert of the AND gate. So that will be 1 1 1 and 0, right? Understood, or should I explain it in detail? Just the note of the output of the AND gate, right? Okay, everyone understood this thing. Next is NOR gate. NOR gate is generally the note of OR gate. This is OR gate, and if I apply a note at the output, so here we are getting A or B, and it is A or B complement. That can be represented as A P bar. So what is the circuit symbol for this NOR gate? This symbol you generally see. This will NOR gate. And we are having the input A and B, and the output Y has two expression, A or B complete bar, right? And the alternative symbols for this NOR gate is going to be, you are having a AND gate here, and we are having two bubbles at the input like this, A and B. This is also results in the same thing, that is A bar and B bar. By using the De Morgan's, which we can be replaced by AB complement. If I make a truth table for this one, that truth table is A, B, output Y. 0, 0, 0, 1, 1, 0, and 1, 1. Output Y is going to be how much? That is going to be 1 here, 0 here, 0 here, and 0 here. Check and let me know.
Right, sir.
Right? Okay. The last two gates are XOR and XNOR. So whenever we are having XOR gate, the symbol for XOR gate is A, B, output Y. And if I make the truth table A, B, 0, 0, 0, 1, 1, 0, and 1, 1. The output Y is going to be 1 when your both the inputs are different, right? Whenever at the input you are having 0, 1 means both the input are different, the output will be 1. Both the inputs are different, output will be 1. And the logical expression for the output is A bar B plus AB bar. This is the logical expression of the output of a XOR gate. Similarly, we are having XNOR gate. XNOR gate is just a node of XOR. This is XOR, and at the output we are having the bubble. This is A, this is B. So output Y, output Y. If I make the truth table, that will be the complement of this one. It means its output is going to be 1 when both the inputs are same. And the expression for the output is A bar B bar plus AB. So these are the set of all basic gates. Check and let me know if you have any doubt in these ones.
No, sir.
Okay. Write down one question. Realize the following Boolean expression using basic gates.
Three AND gate and one OR gate. Yes, sir.
Yes. So first we are having a AND gate here to do the A and B, right? And then we are having another AND gate here to performing E and C. Then again we are having a AND gate here to perform AC. Then we do the OR operation here. Okay. If anyone have any doubt in this today's class, then you can ask. Tomorrow we discuss
Sir,
something about the yes, please.
sir, am I audible?
Yes, you are.
Sir, is there any simplified expression for X and XOR and
That's already simplified. They may not further simplified, right? You
okay.
can't minimize them. They are minimized. Okay. Anyone else?
Sir, in this question, can we minimize the gates?
Yeah, it's not possible here. You are requiring the 4 gate every time. If you minimize this expression also, you can't minimize. You can say you can do one more thing here. If you are implementing that circuit, that I can do A B, then we can take E plus A into C. First do the AND operation. I'm making alternating circuit for that one, and then first we do the OR operation of that EA. Then we are doing the AND operation for this one with C, and then the resultant will be over here like this. This is also the implementation of this one.
Sir, this A line and joining to OR gates, sir.
What you are saying?
AND ऑपरेशन में ए लाइन जो है उसको ज्वाइन कर सकते हैं सर और ऑपरेशन में.
हाँ हाँ कर सकते हैं. Done. Anyone else has any doubt, then please
नो
ask.
सर.
Otherwise, tomorrow we are going to start the max term and mean terms, right? Then we are moving towards the K-map. After K-map, we will do the number system.
ओके सर.